the forecast of visit duration. We are still in the field of machine learning. And what we know today is today's situation is like that normally if a service task has to be planned or scheduled, these service tasks get a duration that is estimated. It's in most of the cases, it's estimated on the individual experience of the service department, or it's estimated on a historic average. So we take data from the past and just calculate an average, and we say, okay, a repair task always takes 60 minutes. Or an installation task always takes 90 minutes. But the problem with this is that this doesn't take into account if this is really the appropriate duration for this specific customer, or is this the appropriate duration if we plan this task for this or this technician? Or is this the best duration for this machine type or model type? So it could be that, in fact, the repair doesn't take 60 minutes. It could be that if we take all these parameters into account, that this repair task in this specific case takes 83 minutes, or maybe shorter, longer, whatever. It can be in both directions. So this is a case where machine learning also can help, because with the machine learning model we can have a higher duration accuracy by taking all these parameters into account, and in the end this could lead to a better workload of the resources. So, and to explain this from the technical background a little bit more, I would like to ask Laureen to explain the next slide, where we can see how this was technically done. Laureen, please.
Yes, exactly. So what we have here is what we essentially did. We looked at our customer, and you can imagine that each customer of us gets their own model, basically, that predicts the duration of visits for their end customer at the end customers. And what you can see here on the graph is actually basically the absolute planning error for basically the current estimates of how they're done right now. So this obviously you can over or underestimate the duration. I mean, both of which are not good, of course, because you don't only do one task per day, but you do many tasks. And if you do not the best estimation, then your whole planning is of course a bit messed up. But then you have so then you have the machine learning model, and you can see that this machine learning model brings all of these estimates for the visits much closer to zero. So it basically you can see you have kind of this tail to the right, where you have kind of a lot of tasks that do get they do have quite a high error, but the machine learning model takes away a lot of these tests or brings them closer to zero. So in numbers, basically, you reduce the average planning error from 30 to 20 minutes. And one thing to keep in mind here is that behind this, you have to build up quite a lot of infrastructure, actually, because whenever you get a new task, you have to basically also get it to the model somehow. And then maybe a day later, you get the feedback, okay, this task has actually taken this and that long. And then maybe a week later, you go ahead and you readjust your model. So this model always learns from the data and always evolves, because of course, as time goes on, conditions may change. I don't know, maybe there's like a pandemic or something, and you can't use the same model as you did 2 years ago, of course. You have to be, it has to be really dynamic and adapt to the circumstances.